from Florida is recognized for 5 minutes.
Thank you, Mr. Chairman. Dr. Van Dam, when I was in college 40-some years ago in electrical engineering, they said that we're about 30 years away from actually producing electricity through fusion. And now I hear that we're still 30 years away. I'm wondering, has there been any, let's say in the last, I don't know, 10 or 15 years, has there been any progress or notable progress towards the goal?
Well, I was also a student 40 years ago, and I heard the same thing. I think people did not realize how challenging this endeavor is. It is a very complex endeavor. It's often called a grand challenge problem. I think we have made tremendous progress, and the National Academy study, in fact, will be documenting that when they do their final report at the end of the year. We've made great progress in control of plasmas, just like with airplanes, in high-resolution diagnostics, high-performance computing, and and also the technology that goes along with it, the heating technology, the magnet technology, and so forth. We have a recent FESAC report on transformative enabling technologies that will enable us even to accelerate faster.
So, okay, so seems like back then there were these goals that were necessary and things that needed to happen to sustain the reaction. And I'm wondering, what is there one thing or two things that we need to do over the next 10, let's say 10 years from now, in order to say, okay, we've made real progress? Well, could you name those?
That's a great question, and I'm sure my neighbors would be happy to answer as well. I think we need to stay in the ITER project. And the computing is a very, very big priority for us and for the administration, because it lets us take bigger steps forward with confidence, having codes with predictive capability. The experiments, I think, are extremely valuable. We have these very high performance experiments, 100 million degree plasmas, and we're understanding them at a very precise level.
What was the temperature?
Like 100 million degrees. It's quite impressive.
Yeah.
And we have these diagnostics that can actually see exactly what's going on, coupled with the codes that actually can compute both postdictive and predictive and interpret what's going on. And material studies, we need that desperately.
Is that where we're putting the money?
In the 2019 budget, we propose this linear diverter facility at Oak Ridge. It's called MPEX, Material Plasma
At our
Facility, Oak Ridge National Laboratory.
Yeah.
That's one thing we're doing.
Okay. Thank you very much. I yield back.